Alrighty, welcome back to another easy LeetCode problem. If you haven't seen the previous videos, I recommend watching the first minute of one of them. It explains our process of how we use easy problems to practice the interview process or the systematic approach to solving these coding problems for interviews. And yeah, let's just follow that process. First step is to just read the problem description. I haven't attempted this problem before. I didn't even read this before. So let's just get into it. So you're given an m by n integer matrix, a grid, and three integers x, y, and k. The integers x and y represent the row and the column indices of the top left corner of a square submatrix, and the integer k represents the size, the side length of the square submatrix. Your task is to flip the submatrix by reversing the order of its rows vertically. Okay, return the updated matrix. Okay, here's step 2, look at the constraints. So we know, okay, so we see that we're given a position that's inside the grid, and we also, our k is so that actually the subgrid as a submatrix actually is a valid one. We don't have to do any checking of whether it's valid or not. And we have, of course, the length of the width and the height of the grid. There's some constraints on how large the grid is, but for a runtime analysis, we're going to ignore that and pretend it can be arbitrary. Otherwise, all space and time complexity is going to be automatically constant if we assume that the grid is fixed in size or has an upper limit. Cool. So example 1. So here we're giving the grid x1, y0. So that'll be why is that x? Do they use x for the y position? X represents the row. Oh, that's horrible. Oh, this is really horrible. I don't like this. So first thing I'm going to do is I'm going to switch that so that I actually know what I'm talking about here. Okay, and we can also know want to return the grid in the end, right? The updated grid. So we're probably going to modify the grid in place. And okay. So let's say we have x0 and y1, so that would be 0 and 1. And we have k is equal 3, so the side length of the submatrix is 3. And now how do we rotate it? We rotate the rows, so we don't do any 90-degree rotation or anything like that. Reverse the order of its rows, not horizontally, but vertically. So the middle row stays in its place, but the top and bottom rows are switched. Now here in this example, we have the same. We flip the top and the bottom. There's no example where we have more rows, but of course, if we have more rows, then we should flip those as well. Okay, that shouldn't be a big problem. But we could have an even or an odd number of rows, depending on what the value of k is. So I think what we have to do, well, we'll have to iterate over all of the elements in the submatrix, right? That's kind of the thing that we have to do. So if we want to flip, well, we could use a pointer to point to the last row of the submatrix and to the first row of the submatrix. And then we just make these pointers move towards each other until they cross, and then we know we're done. But then we also have to iterate through all of the elements in each of the rows. So what we'll have, I think we have a space complexity of 1 if we modify the grid in place. We don't need any extra data. And we'll have a runtime complexity that is entirely dependent on k. So it will be k squared, because that's how many elements you'll have in the submatrix. That's how many elements we'll have to look at and touch. So yeah, that's that. And normally you would ask the interviewer if he's happy with that approach. And of course it's yes, it's fantastic. Please continue. And then you do that, right? So let's do that. Can't know the fact that they mixed up left x and y. Doesn't make any sense. And we also don't have to care about what the actual width and the height is, because it's guaranteed that the K will never lead us to being outside of it. So that's perfect. So we say top. Yeah, we have a top. We have a bottom. I'm just going to abbreviate this like in this really cool style. So the top row will be our Y position, and the bottom row will be the Y plus a K. So in the example, just double checking if I got it right. So Y is 1. Y is 1. And so that will be the top. And the bottom will be 1 plus 3. So it will be 4. 0, 1, 2, 3. Oh, wait. 1 second. 3. Oh, yeah. So it'll be plus K minus 1. That's how that works. Right? Because everything is 0 indexed. So if we start at index 0 and we have a K of 3, the bottom index should point to index 2 and not 3. So that's why I have to correct with -1. Easy to make that mistake. And then we do while top is smaller than bottom. If it's equal, that means we're in a row that cannot be, or that should not be moved anywhere, right? So that's our little condition. And then we'll do our little logic here of swapping the elements in the top and bottom row, or against from the top against the bottom row, and vice versa. And then we have to update the top, and the bottom will move towards the top. So that is going to be our loop. And so now we need to traverse through the columns of our submatrix for px in range k. So our delta x. And for px, we're going to add x to our dx. So remember, let's take this example. So here, remember, I'm flipping x and y, right? I hope that doesn't confuse us. So the value for x will be this value. So it will be 0, 1, 2. So this is where we start. And now we have to iterate over 2 elements. So that is the case. So the dx will go from 0 to 1. And we add 0 and 1 to our offset value of 2. So that covers those 2 elements. So, and this will be the position. Now, the top value will be in our grid. We have to select the top row. And we have to select the value at position px. And bottom value will be simply that. And then we have to flip them. Now in Python, we can do it like this. So we don't have to use like intermediate variables to do that. We can just say, okay, that value gets assigned the bottom value, and the bottom value gets assigned the top value. I think that should work. I've seen weird circumstances where this doesn't work, where I have to actually break that out into variables before I do the flipping, right? Where I have to do like a, b, it's equal to b, a, a, b. But I think we should be safe. If it doesn't work, then it's because it doesn't work, and then we have to change it. I think that should be everything. I didn't write the runtime complexity down, so it will be O of k times k time and O of 1 space. That should be it. Do we make any mistakes? I don't think so. Grid, yes. Grid. Let's run the test. Index out of range. Okay, that's not great. Oh, I see. See this? Top value is moving towards 0, which is not great. So we want to move the top row always down. Oh no. Oh no. Well. What could be the problem? What could be the problem? Okay, so now the debugging starts. First, I'm going to try if this is the cause of the problem. Me trying to be smart. And then, if that is not the case, then the next step to look at, to investigate is whether I'm making any indexing mistakes, right? Maybe my switching of the X and Y's mess things up. Let's see. Index out of range. So let's see, top and bottom. So the top is the Y. Let me just see. Okay, so the top and the bottom value, they are our Y coordinates, and we've switched them over before. X represents the row and Y represents the column. X represents the row and Y the column. Right. So this should be correct. Okay. And so now our px value is there in the range of x and x plus k. Now the top value is the smaller. That's why it needs to be increased. And the bottom is the one that needs to be decreased. All right. So I think we found the error. Let's retry. Submit. And if that works, we're going to try our other way of writing it again. So we're going to try that. I kind of want to know, because I haven't tried this in a while. So, yeah. So the bottom gets assigned the top gets assigned the bottom. All right, okay, cool. So yeah, that stuff happens, and that's why you practice. So over time, you need to, you learn to pay more attention to these errors. My brain is slightly fried, which is why I didn't spot that. So top row is of course the one above the bottom row, and the top row needs to increase, and the bottom row is the one that needs to decrease. While you were watching this video, you were probably seeing the error much earlier than I do. But yeah, that's just how that goes. So as always, let's have a look at some of the example solutions that people have. Short and simple in space swapping Python O of n squared. Why n squared? What is the n? Space complexity. Okay, that's not a good solution. And I also think that this solution, the space analysis seems wrong, because he's updating the grid. He's exactly doing the same thing. So the space complexity is wrong. The analysis is wrong. The n squared, does he say what the n is? Doesn't say what the n is. So that's also then not really useful to know, because n is defined in the problem. So O of n is definitely wrong. The time complexity is only dependent on k. We have k by k elements. We only look at k by k. So we have a better analysis. Let's look at something else. I'm looking for something where it says like that it has like a good complexity. So k squared, yeah, that's what we have. So this is a dude or a dudette who did the right thing. Also the top to bottom approach. Okay, but he didn't correct the x ones. I don't understand this. X is horizontal, y is vertical, always. Exactly the same approach that we have. Is exactly the same one, yeah, cool. Yeah, anyway, so that's that. And yeah, enjoy coding this for yourself. And if you want to make it a little bit harder, try rotating this submatrix. which is, I think, its own LeetCode problem. I don't know which number.